Let's see how to solve this problem, which says a monochromatic light of wavelength 600 nanometer is directed towards a double slit and forms an interference pattern on the screen. So monochromatic means single color, and the wavelength is given as 600 nanometer. So we have to write 600 multiplied by 10 to the power negative 9. Next it says two slits are 0.080 millimeter apart and the screen is 2 meter away. So we can see the two slits, separation between the two slits is given by 0.080 millimeter, which we have to convert to meter. So we write it as 0.080 multiplied by 10 to the power negative 3 meter. The screen is 2 meter away, so the value of L is 2 meter. It need not be converted because it's already in meters. And the value for M that we get from part A, it is asking how far is the third dark fringe. Therefore M will be equal to 2. And now we have to just use the formula for the position of the dark fringe given by M plus half lambda L over D. We substitute the values which we have already taken from the problem and we get the answer as 0.0375 meter. So we need to remember how to get the value of M from the problem. We can see that it is saying third dark fringe, therefore the value of M is equal to 2. If it was third bright fringe, then the value of M will be 3. Let's look at the next question. Calculate the distance between adjacent bright fringes. We have the formula delta y equal to ym plus 1 minus ym. Why are we using this formula? Because it's asking for adjacent bright fringes. So we find the position of mth bright fringe and m plus 1th bright fringe and then we subtract it. So m plus 1 and m represents the adjacent bright fringes. Now because it's bright fringe, we can use the formula for bright fringes. The position of bright fringe is given as lambda L over D multiplied by m plus 1 for the m plus 1th fringe and lambda L over D multiplied by m for the mth fringe, which we can rearrange. We can see that m gets cancelled and we get the formula for delta y as lambda L over D. We can substitute the value which we have got from the problem and get the answer. The next one, does a larger slit create a larger separation between interference fringes? So we have got the formula for bright fringe. The position of bright fringe is given as m lambda L over D, where D is the slit separation. So we can see that the bright fringe position depends on the slit separation. But the problem is asking you, does a larger slit? So let's look at the diagram. In the diagram, we can see there are two slits and the distance between the two slits is D, which appears in the formula. But does that mean that we are having larger slits? Larger slits means you are going to increase the gap or increase the slit size, which does not change the slit separation. And therefore, we can see that Y does not depend on the slit width, rather it depends on the slit separation. Therefore, our answer for part C will be no.